All right, thanks everyone. Sorry if you're sick of seeing my face, but we're going to be talking today about some updates on the SV node, and then also some general updates about this Bitcoin protocol documentation that we're going to be releasing. So for some of you guys that may not know, if you're in this room, so the Bitcoin Association acts as stewards of the Bitcoin SV blockchain. We guard the original Bitcoin protocol, and ultimately I just want to talk a little bit about, why are we focused on Bitcoin SV? So Bitcoin itself obviously has a long history, but ultimately Bitcoin SV was started to restore the original Bitcoin protocol, which has the original Bitcoin scripting language to enable complex use cases, and also to massively scale the blockchain. We've increased the block size to an unbounded number, so miners are free to choose whatever block size that they want, as it was always intended. But one of the main features of Bitcoin SV is stability. And what that means is we've restored, or we're working on, you'll see as I get to the end of this presentation, restoring the very last bits of the original Bitcoin protocol. And we're making a commitment to lock it down and never change it ever again. And the reason why stability is important, just like the internet protocol, what we want is users and businesses to be able to transact on the blockchain, create things like trusts, have businesses start to invest in building applications on the blockchain, and know that we're not going to do something to break their applications, their use cases in 4 years, 5 years, 10 years, 20 years. Stability is extremely important, not just for businesses, but for users, right? So you can imagine a world where maybe I set up a trust for my grandchildren or something like that, and maybe I sign a transaction, I put it offline, but maybe in 40 years that transaction has to get broadcast to the blockchain. So stability is extremely important because we want to ensure that we're not doing anything to break existing functionality. And that's what's happened, unfortunately, on just about every other blockchain system, but especially on the Bitcoin core blockchain. We'll see the developers interject and make changes that break a lot of use cases and functionality. Security, one main focus of the SV node project since it started in 2018, was world-class security. So we have one of the largest bug bounty programs for any blockchain that exists in the world. So if you are a white hat hacker, definitely feel free to take a look at the code. We're really committed to a very stable, secure node software. And I'd like to give a lot of credit to the team that we work with at nChain that develops the software. And finally, another key piece of Bitcoin SV is instant transactions. So the original Bitcoin white paper mentions the micropayments a lot of times. Bitcoin was always meant to be available for small, casual transactions over the internet, and that doesn't work unless we have safe, instant, zero confirmation transactions. Another thing, unfortunately, that over the last number of years, if you've been involved in this space, there's some kind of myth that zero confirmation transactions don't work, but it was clearly identified from the very beginning how that works. So before I talk about the software itself, it's important to understand who the software is for. So this is the SV node software, but the node, what is a node, right? So if the software is meant to be run on a node, unfortunately there's also another myth that exists in the blockchain world about what a node actually does. So in the Bitcoin white paper, there's 5 steps that outlines how to run the network, and it outlines exactly what a node does. And the very most important thing is that they collect transactions into blocks and build on top of the blockchain. And the reason why that's really important is because in order to do that, you need large amounts of hashing power, which is not necessarily financially accessible to people like me. So the node software is not meant to be run in my basement. It's not meant to be run by my home computer. It can be right now, probably, because thanks to a thing called Moore's Law. But ultimately, we're designing the software to be run by large data centers, by professional mining systems. Satoshi Nakamoto was very explicit about who he envisioned running the node software. And ultimately, we envision this being large corporate entities that will be distributed across the globe. So I just want to call out, the node software is not meant to be something that you can run on a Raspberry Pi at home. It is designed to handle large scale. So let's talk very quickly about the Bitcoin protocol itself. So when I say the Bitcoin Association acts as the stewards of the original Bitcoin protocol, we kind of just keep saying that, but it's probably not explicitly clear what the Bitcoin protocol is. So what we've been doing at the BA over the past 6 months is trying to make a plan for essentially publicizing what the protocol is. And ultimately what we want to do is to enable anybody to build a competing node software. We don't want to force miners to run the Bitcoin Association's node software, but in order for someone to do that, they have to know, okay, what protocol do I have to adhere to, right? And this would be the same as any other peer-to-peer network or peer-to-peer protocol. You want the ability for someone else to create a competing implementation, but they need to understand exactly what they need to be able to do, right? So that's kind of the guiding principle of this project is, number one, if we're gonna go out and say, well, we're the stewards of the Bitcoin protocol and whatever else, it might help if we clearly define what that is. Even though it might be clear to some more technical people, we wanna make sure it's explicit. And also we want this to act as a reference documentation for, if you want to create some kind of competing implementation. If you think, the SV node software doesn't do what I want it to do, or the upcoming Terra node software doesn't do what I want it to do, that's fine, go build your own. Just make sure it adheres to the protocol itself. And the documentation for that itself is going to come later this year. So look forward to that. All right, so a little bit of history about SV Node itself. Since we last spoke in Dubai, if you happen to be at that conference. So in November, we released version 13, which enables support for digital asset recovery. You may have heard me talk about that a few other times over this week. But we released essentially a toolkit that we called the DARA toolkit. It had a software mechanism called the blacklist manager that connected to the node software, and that would enable a miner to keep, if they're running multiple instances of the node software, to keep things like blacklists and whitelists in sync. In March, we released some performance improvements and fixed some node freezing issues. So we saw a number of issues where the node would freeze up under some certain circumstances. We fixed that in March, and then in April, we released another minor update, which was basically just some performance improvements and also some OS updates for things like CentOS and Ubuntu. So scalability, right? So ultimately, like I said, the reason why we decided to even fund the development of the node software was to focus on scalability. The history of the SV node software was basically, let's get to 2 gigabytes, let's get to 4 gigabytes, and then let's just leave it up to the miners. We don't want to have any say in what the maximum block size is. That should be up to the people actually processing transactions. This slide is actually out of date since I submitted it last week. So there was a world record of 50 million transactions achieved by a team called Mint Blue in March, but I believe, if I have the number right, I think it's 85 million was done, I think last week, by the team at Bionex. So the SV node software does handle scale, but it's not where we want it to be. So hopefully you guys were here earlier for my colleague Jake's presentation on the Terra node project. Ultimately, the node software has an upper bound. It's a monolithic architecture. It's not designed to scale horizontally, and it has a shelf life. Just being honest, the node software is a remnant of the 2009 software that Satoshi Nakamoto released, and we've also inherited a lot of bad logic in the node software as a byproduct of the core development team and other development teams building workarounds for things like fee logic and things like that. The SV node software, we understand that there's an upper bound in scalability, and yet we're still able to handle quite good scale today, even with this monolithic architecture. So I want to talk a little bit about digital asset recovery, since I mentioned that was a big component of our version 13 release. The version 13 release contains a specification for this thing that we call a confiscation transaction. It's not probably the best term, but ultimately what it means is if a person has gone through the legal process to identify ownership over coins, there is a technical specification for how can we get the coins out of an address or a key or a script into a key that you hold. So that was the main component of that release. And right now it's currently enabled by the node software in conjunction with this blacklist manager tool that I mentioned. But I want to talk about the 3 things that we're working on today. So the first is the development of something called an alert mechanism. I'll talk about that in a minute. We're also going to be enabling support for free transactions. Talk about that. And also, as I mentioned before, there's some a little bit of pieces of the original Bitcoin protocol that we need to finish restoration of, and we're putting together a plan for that as well. So first, let's talk about the alert key mechanism. You might hear me call it 5 different names. We're still figuring out the exact term we'll use, but there was the original alert system itself was developed in 2010 by Satoshi, and I encourage actually everybody, if you're a Bitcoin history nerd like myself, go back and look at the original thread where he announces it, and it's a very colorful and interesting discussion. But ultimately, the purpose of the alert system when it was developed was to provide 2 really main functions. So number one, it was an emergency release because there was a critical bug in the software that had to get fixed. And so Satoshi needed a way to alert nodes in the network to update immediately so they could not be on the wrong chain. There was a value overflow instance, so there was inflation that was occurred because of a bug in the software, right? So Satoshi didn't rely on decentralization or whatever, like, oh no, well, there's a bug, code is law, we're gonna allow the coins to inflate. Instead, he implemented the alert mechanism, which is a very easy way for him to communicate with all the nodes in the network and say, upgrade the software, you're on a bad piece of software. Ultimately, the way that this worked originally and the way that it'll work when we re-implement it is a signed peer-to-peer message. So there'll be a new peer-to-peer message type over the peer-to-peer protocol, and we'll sign it with an alert key. I'll talk about that as well. And ultimately, the important thing this does is it allows us to prevent chain splits, especially in the case if there's a bug, but also if there's one real problem that we have on the Bitcoin SV network is we have about 1% of the global SHA-256 hashing power. We've seen a few incidents already over the last 3 years where miners come in, a large amount of hash rate will come in and attack the network, essentially. They'll cause issues. We saw one a couple years ago, which was actually an egregious attempt of basically someone built 150 blocks in secret, published those 150 blocks at one time to the network, and attempted to double spend in exchange. So that's an example where we need some kind of way to coordinate a response to that with the honest nodes in the network, and that's the purpose of re-enabling this system. Ultimately, that's a main piece of why we're doing this. We want to be able to protect ourselves in the case of a large amount of hash rate coming in and trying to cause problems, just like it was used in the past in 2010. We're also going to merge the existing DAR functionality into the alert mechanism. That way, we don't have to rely on these third-party components for communicating with the network. Instead, we can just do this over the peer-to-peer network, which we already used to communicate. And I just want to reiterate again, it basically solves this idea of chain splits or whatever else. We have a way to easily communicate with nodes in the network and ensure that the honest chain lives in the case of some malicious attack. Free transactions. So this is another thing that came up on the insistence of Dr. Wright. He was very adamant we get this done today, yesterday, tomorrow. And the reason why is because free transactions were allowed and actually encouraged in the original days of Bitcoin. Transaction fees are obviously a way to incentivize the inclusion of transactions into the next block. But right now, especially on Bitcoin SV, we have a lot of extra block space. What that extra block space is, I don't want to centrally dictate or whatever, but miners themselves processing a 10 megabyte block versus a 200 megabyte block is almost negligible to them. So what we want to do is provide the ability for miners to essentially set aside a size of transactions that they'll allow for free, and that hopefully will encourage businesses, users, developers to just start trying things out and look, you can do it for free, you don't have to pay any transaction fees or anything like that. Ultimately, the way we're going to do this technically is you'll have a separate mempool from which it is deprioritized. So if you want the transaction to be included in the next block, pay a fee, the traditional way that we've done fees on Bitcoin SV for years now. But if you don't really care when it gets mined in a block, you can use a transaction template that we'll be publishing. So we'll basically specify what kind of templates will be enabled for that will go into this free mempool, and then as long as you conform to that template and the miner is accepting it, then that'll work. So this will be a cool way to essentially start getting this idea of like a minimum block size. Not that we'll have it enforced, but that what we're saying is if there's gigabytes of transactions in the mempool, and we know that to a miner it's really no difference if they're processing an extra 500 megabytes, then do it. And then lastly, this is the big one to me, at least. I'll be frank here, and I'm sure this will resonate with some people in the room that have been around Bitcoin SV for a while. So a confusing thing is that we were saying, we want to restore the original protocol, we want to lock it and set it in stone, but there's a few pieces left that there wasn't really a plan for. The first is this thing called opvir. So there's a remaining opcode from the original scripting language that essentially pushed a version number to the stack. This wasn't re-enabled in the Genesis update for a number of reasons. The first of which was we kind of had to crush a lot of stuff into a small amount of time, and that's one was just left out. So we're going to re-enable opvir and also re-enable some of the other opcodes like opleft, opright, which we unfortunately in the Bitcoin Cash days merged into some other opcodes. So getting the rest of the opcodes and get it right back to the original scripting language. One benefit of something like opvir is we can start doing things like overlay networks. So by pushing a version to the stack, you can actually start having transactions that follow certain rule sets based on maybe some overlay node in the network will process that transaction differently than the miners in the network. So it's actually a really, really interesting thing. Enables a ton of use cases. I'll be happy to talk about that if you want to come find me. But that's one piece that we're looking into. The second is removing this idea of a clean stack. So another leftover thing from the days of Bitcoin Cash was they made a requirement where the stack had to be empty in order for a script to be valid. This makes somewhat sense if you're designing things for a certain way, but the original Bitcoin system actually didn't require this. So it meant that you could actually have things flow from one script into another, which if you're a developer, you might start thinking of interesting use cases for that. And then the third is allowing opcodes in unlocking scripts. So there's another thing that's, again, hard to find out about on the internet, so like the history about it, but ultimately the original Bitcoin system allowed you to have opcodes in the unlocking script. It didn't require you just to have push data. So right now, if you try to put anything into the unlocking script, it forces everything to be just data. So that's obviously helpful if you're trying to unlock coins locked to a public key, so public key, then signature. But we might want to actually start introducing more interesting type things if you can say, I want to actually do computation in the unlocking script as well. So I don't really have ideas right now, but you might come up with some yourself. And ultimately, our goal is to get right back to the original. The last two, I have them in different colors because they are not easy ones, but we are going to do this, but this will be probably done separately than the first three. Number one, we want to restore the original difficulty adjustment algorithm. So a little more history. In the Bitcoin Cash days in 2017 and again in 2018, the difficulty adjustment from the original Bitcoin system would update every 2016 blocks. So the difficulty would, that was a way for us to say, okay, when more hash rate comes onto the network, we can update the difficulty, and it's basically Bitcoin's main security function. When Bitcoin Cash forked away, fork is not the right word. When Bitcoin Cash emerged, they also implemented a new difficulty adjustment algorithm which adjusted dynamically. And the purpose of that was actually to facilitate coexistence of the BTC chain and the Bitcoin Cash chain. It had a lot of unintended consequences. Today on BSV, we are still dealing with the effects of this, but ultimately we want to put this right back to the original, the 2016 blocks. You might, if you're a developer, you might have some questions about this, talk to me about it after. But like I said, this needs to be thought and considered and made a plan for, but what I want to hopefully convey to all you guys is we're aware of it, we're going to make a plan, we want to publicize this plan. It doesn't have to be something that we're all just thinking about, wondering about, and not afraid to speak about it out loud. And the very last one is replay protection. So another thing that happened, more history, in order to, again, facilitate the coexistence of the multiple Bitcoin implementations, the Bitcoin Cash developers also added a flag to the signature algorithm, so that way a signature on BCH wouldn't be valid on BTC. We also have this in BSV. And we're going to remove that at some point because we want to go right back to the original signature algorithm. There's no reason for us to have something like that in there. But again, that has ramifications, and it's not something that we want to do in haste without considering it. But I do want to at least be transparent that we are going to do it. So I have about 9 minutes left, and I thought I could open up for any questions if you guys have it about any of the things I talked about. I think we have time. There may not be any questions. Yep.
Hi. Will the alert key being reintroduced be integrated at all with the miner ID protocol so that miners can send alerts to each other?
I mean, they could be used in conjunction with each other. So definitely a thing that we were going to want to enable is miners in the future to be able to alert. Let me take a step back, sorry. So what we do already have in the node software is something like called double spend detected message. It actually acts very similar to the way this alert mechanism will work, which is when a miner detects a double spend, they send a message over the peer-to-peer network to all the other miners saying, there's a double spend detected, here's some information about it. To provide some more context, the miner ID system is an optional mechanism for miners to identify themselves, to build more trust with both the other nodes in the network, but also users if they're going to communicate via MAPI. So the answer to your question is, we're not going to require the use of miner ID ever, but it is definitely something that they can optionally use. We are going to want to enable at some point in the future the ability for miners to be able to, like you said, send signed messages to each other. So definitely that's something we want to do in the future, but not in the first instance of the mechanism.
Okay, thanks.
One in the back.
Hi. So for the BSV, in relation to consensus protocol, how will businesses be able to use it? I'm trying to rephrase it better.
It's okay.
Yeah, but is there going to be a need for miners when businesses are using the BSV?
Yeah, so definitely. So the purpose of the mining network itself is to have a distributed system to validate transactions and to timestamp transactions. So if I'm a business, the reason why I am reliant and why I would want the distributed mining network to exist is I want to be able to send a transaction and get it timestamped and included into a block, and then I have a record in the blockchain that I can reference. How I use it, like you said, there's probably 1,000 different use cases for the blockchain for different businesses and systems, but we want the mining network because it provides settlement. So there's one ledger, and it gets written to by this node network. So what we need, especially going 100 years into the future, is that we need the economic system that is Bitcoin to, I'm going to make a transaction, I'll broadcast it to the network, and I need to be relying on economic incentives for this distributed nodes network to include it into the blockchain, timestamp it, include it into a block, and build on top of it. So ultimately, we do need the node network. As far as why businesses should build on Bitcoin SV, more generally, this may not have been exactly your question, but another important reason why we believe in scalability of the blockchain is because a company like Facebook, Twitter can't use blockchain technology today. It's impossible. There's no other blockchain that does anything close to the amount of transactions per second that the SV node software does. And then that is peanuts compared to what my colleague Jake presented on with Terranode. We want to enable, like Dr. Wright said last night, 100 Twitters, 1 million Twitters to be available on this public network. And right now that's only enabled by massive scalability. But to answer one last piece of your question that I would say is, we do need better tooling. There needs to be better tooling to interact with the blockchain, to build on the blockchain. That's something that any developer in this space knows. So I agree it needs to be easier for businesses to be able to build stuff on top. But we'll get there, hopefully with the help of people in this room.
Connor, thank you. Quick question. BSV, can you do sovereign chains? Can you do limit the mining to specific jurisdictions or nation states?
Can you repeat the first part? You said summer chains?
Sovereign chains. The issue that we're facing right now is, sorry, just to help frame the question a bit. Sometimes there's a single instance of a node operating in a third-party geography. That third-party geography wants to claim the tax on it. And obviously this is a problem with some of the Ethereum chains and some of the other centrally managed chains. So to address that problem, what I'm trying to work out is whether you've got any or want to comment on chains existing in a single instance, in a single sovereign nation state, or limited within the jurisdictional parameters of that nation state.
Well, I mean, I'll caveat, I am definitely not a lawyer, political expert, or anything like that. I mean, I don't know if I can give a good answer to that. I mean, ultimately, to us, especially at the Bitcoin Association, we don't care where your node is. It could be anywhere. I mean, there's definitely going to be requirements if you're running a mining operation out of the US, that's going to be different than if you're running a mining operation out of China or wherever. But ultimately, all we care about is, are you performing the functions of a node and are you following the rules of the network? Another benefit of the way that Satoshi designed the system is miners act basically equivalent to internet service providers. Their job is to timestamp the transaction and include it. They don't have visibility into what's in the transaction. They're not required to validate data inside the transactions. So they're actually protected by a lot of existing regulations around internet service providers, which, you know, if someone communicates, explicit, illegal data over an ISP, the ISP isn't responsible. They're just the piping. They're not looking into every single thing and responsible for blocking traffic or things like that. So, I guess I'd have to learn more about what you're talking about, the sovereign chain idea. Maybe we can talk about it after, but maybe that generally answers your question. I don't know. We have a couple more minutes if anyone has one more question or... Yep, sure.
I mean, obviously it's going to depend what transaction volume looks on the live chain, but is there any plan to continue maintaining the legacy node after Terranode gets released while it's still possible to use it?
That's a good question. Something I'll follow up on, because I mean, there needs to be, I think, don't hold me to this, but probably what we should do is just make it an open source project managed by someone at the BA, and if people want to contribute to it. One problem we do have, to be honest with you, there's really not much contribution to the SV node, so nChain does a lot of the development, but we are open for pull requests and things like that. So if someone does want to submit a pull request, communicate with us at the BA, we can help you facilitate that today. But we will at some point sunset the development by nChain on the node, I would imagine, because we don't want to just keep sinking money into the project if...
But there's no current plans?
No current plan, but I'll take it as something that I need to do, so yeah. Thank you. More work, yeah. Anyone else? One more minute. All right, well, thank you, everyone.